The first page, they fill in a lot of the stuff for you. It's kind of just getting you going on it. And then after the first three, you got to do them all on your own. But they're all basically done the same way. Some are longer than the others. It depends upon what kind of givens they give you. But when you do your proofs, you're always going to be given something, and you're always asked to prove a triangle is congruent. So those have to go in your proof. If you were just looking at this problem, and they asked you what reason would make these two congruent, just by looking at the picture, what would it be? Huh? No, we don't know three sides. We only know two sides.
Side angle side?
Side angle side, because vertical angles are congruent. Remember, the two things that you always know just by looking at them is vertical angles, and it's not always like this, but a shared side. So, in your proof, they started off with one of the givens, and then they put in there that MO is congruent to QO, there and there. Now, what's the reason why we know?
Definition of midpoint.
Definition of midpoint. If O is the midpoint, that means it cuts it into two equal pieces. So this is just definition of midpoint. Then they put the second given right there. And then they did the same thing. Since O is the midpoint of PO, NO has to equal PO because that's also the definition of midpoint. So, what they have so far in this proof is a side and a side. Remember, you gotta show three things before you can put your proof statement. SSS, SAS, ASA, AAS, or HL. So, the last one, we know angle MON is congruent to QOP because? No. No. How come we know this angle equals this angle?
Because
What kind of angles are they? Vertical angles are congruent.
That's what Mickey said.
So there we've got the third thing. Now remember, in your proof, they don't have to be in the order that you say it. This is SAS, and here we have SSA. They don't have to be in that order. They just have to be listed in there. So then, once we have those three, you put your proof statement. And the reason why they're congruent is because of side angle side, SAS. So, the next one, in this picture, O is the midpoint of MQ, O is the midpoint of NP. They're wondering, prove that triangle MON is congruent to triangle QOP. Now basically, this is the same exact proof as this one, it's just a different picture. They drew the picture differently. Again, looking at these two, what would make this triangle congruent to that one? What would the reason be? Side angle side. Because again, vertical angles are congruent. So they started off with the given. O is the midpoint of MQ. That's given. Since O is the midpoint of MQ, you know that MO has to be congruent to QO. That's the definition of midpoint. Then for number 3, they gave us the reason given but not the statement. Well, there's only one given left. It's got to be that one. O is the midpoint of NP. So since O is the midpoint of NP, we know that this piece has to equal that because midpoint cuts it in half. So you would say NO is congruent to PO. Definition of midpoint. So again, just like up here, there's two sides, and then here's the angle. But we need to put the reason. Why do we know that MON is congruent to QOP? Why do we know those angles are congruent? What now? Vertical angles are congruent. I hear some people saying this, and you said it up here. When you're showing an angle's congruent to an angle, or a side's congruent to a side, it's not going to be SSS or SAS or ASA. The only time you're going to put that in there is the last reason to prove why the triangles are congruent. Those are reasons or ways to prove triangles are congruent, so you can't use them up here. So the reason why these two triangles are congruent is side angle side, SAS. So in this one, if you were just looking at this picture, there would be two ways to prove these triangles are congruent. They give us a side. Now these little arrows mean the sides are parallel. It doesn't mean they're congruent. So you don't count it as a side. But anytime you see parallel lines, 99% of the time in these proofs, it's alternate interior angles. There was only one problem of all these that we did where there was corresponding angles. That was the one triangle that was like this, where this was parallel to that. So that made these two angles congruent because of corresponding. Every other one has been alternate interior. If this line's parallel to this angle would equal that one because they're alternate interior. And also, this would equal that. So I could use angle, angle, side. But also, vertical angles are congruent. So ASA also works. So you only have to do it one way. So we'll see what they did in the proof, which way they did it. They started off with the given, LA is parallel to SN. And then, how do we know that it says L is congruent to N? Alternate interior angles are congruent. Then they did the second given. So far we have an angle here, we have a side, and then down here they put in another set of angles. So what they did is they took angle LRA, which is this angle, is congruent to NRS. So what's the reason that they're congruent? Vertical angles are congruent. So there we have our three things. So you put your prove in, that always goes last. And what reason proves? Angle, side angle, angle, side angle. Now, this one on the back page is the easiest proof there is. Yep. They give us two things. They give us that AB is congruent to CD and BC is congruent to DA. You could write given twice, or you could just put the brackets and write it once, whichever you prefer. But they give us two things right away. So then what's true in this just by looking at it? Shared side. AC equals AC, or CA, whichever you want to call it. And if you forget what it's actually called, shared side works. You don't remember what it's actually though, the proper statement? When you look in a mirror, you see reflection. It's reflexive. But again, if you forget that, you could put it's a shared side. So there, right off the bat, we've got three things. So you can put your prove statement in. And the reason why they're congruent is SSS. So the next one, these sides are congruent and they're parallel. So anytime you see parallel lines, you got to look for alternate interior angles. Which last hour or fourth hour, some people were saying that these two were congruent. These are not alternate interior because there's no line that connects those two. The alternate interior, you can think of it, this helped after I told them, think of it as a Z. If I take this parallel line and then come down to this one and then there. There you can see a little easier. There's the angle formed there by these two, and here's the angle formed by these two. Those are the alternate interior. You gotta have the two parallel lines and then a line going between them. So, if we start off with our givens, that gives us just one thing, a set of sides. Now you don't have to do this, I just do this to keep track of that I've got enough. You don't have to put the S and A on the side if you don't want, but sometimes helps. So now, it doesn't matter what order you go in, but since these two lines are parallel, what two angles will be equal? ABC will be congruent to DCB or BCD, whichever you want to put. And that reason is, what kind of angles are they? Alternate interior angles are congruent. Then we have one more thing that's true in there that you can tell just by looking at it. Shared side. BC equals BC. That's reflexive. So there I've got my three things. They don't have to be in the order that I'm putting them, but they might be. In this case they are. Once you have the three, you put your prove statement. And they are congruent because of SAS, SAS. So then this last one, they tell us that two lines are perpendicular. And that C is a midpoint of BE. So far, we don't have anything that helps us. We don't have any angles congruent or any sides angle equal. But this information tells us, since AB is perpendicular to AD and DE is perpendicular to AD, what do you know about those two angles? They're 90, so they're equal, right? So angle A is congruent to angle D. Now this, whenever they have stuff with midpoints or perpendicular, or on the next page they have a bisector, we know they're congruent because they're both 90 because they're perpendicular, right? Perpendicular means 90. So anytime you have something like that, you just put definition of perpendicular. If you forget to put that, you can just say they're both 90. Because that is the definition of perpendicular. So there's the first thing that we learned. Two angles are congruent. Then, since C is the midpoint of BE, midpoint means it cuts it in half. So that means EC has to be congruent to BC. And again, it told us it's the midpoint, so we know they're equal because that's the definition of midpoint. So there we've got a side. So we got two things. You just need one more, either an angle or a side. So what else is true in this that you know just by looking at it? Vertical angles. This angle equals that angle because they're vertical. Angle ACB, remember, or you could call it BCA, it doesn't matter, is congruent to ECD. Because vertical angles are congruent. So now that we've got three things, two angles and a side, we can put your proof in. And what is the reason that makes these two? Huh? It's got, huh? ASA? ASA means it would have to have the side in between the two angles, which it doesn't. This would be ASA. Of your choices, SSS, well, we have two A's, so that takes care of that. Angle, angle, side, AAS, or you can do it backwards, SAA. So, on your second sheet then, a lot of these are the same. You can use this first sheet to look at. I just want to point out, again, when it tells you something bisects, that means it cuts in half. So since PN bisects this, you know this angle equals that angle because it's definition of bisector. And here you've got two sets of parallel lines. So since this line is parallel to this one, I know these angles are equal because they're alternate interior. And since this line is parallel to this one, I know these two are equal. So these two things, parallel lines, are going to tell you that two sets of angles are equal because they're alternate interior. So they're all done basically the same way. When you're done, you can staple them together and hand them both in.